Welcome to the next lesson in our series on the hydrosphere. As we know, water is so important for life on Earth. In this lesson, we look at the water cycle and the chemistry that explains some of the reactions in the cycle.
We are going to start at the source of a river. Take a moment to think about where rivers come from. You might want to take some time to discuss it with your class. The place where a river starts is called its source. Here, groundwater bubbles to the surface and starts to move down to the ocean. Streams grow as they collect water from precipitation. When I use the word precipitation here, I'm of course referring to water that falls from the sky in different forms, like rainfall, snow, and hail. I am sure you know that although some water from precipitation runs over the surface of the land, collecting in streams and rivers, a lot of water also evaporates back into the atmosphere. And some of the water seeps into the ground and is collected as groundwater. In some places, the rocks contain soluble minerals. These compounds are dissolved by both groundwater and rivers in contact with the rocks. Over many years, underground caves can form. Both groundwater and rivers carry the dissolved mineral salts into the ocean. This explains why the oceans are salty. Moving water is extremely powerful, and this causes erosion, and so water is continuously changing the landscape on Earth. Because there is no water cycle on other planets such as Mercury or the Moon, their surfaces have remained largely unchanged for billions of years. As rivers flow, they transport large amounts of sand, silt, and mud to the oceans. These particles do not dissolve in the water, but are carried in suspension. When the rivers meet the ocean, they deposit the suspended material. Over time, these build up in layers and harden to form new sedimentary rock. Rivers carry fresh water, which can be used by humans and animals as drinking water and used for other activities such as irrigation. But as rivers flow to the oceans, they become more salty. How do you think this is possible?
One of the important facts of most of the water in our biosphere is that it contains dissolved substances. Nelly tells us how this comes about.
Well, water is a very good solvent. Remember, many solids such as sand are in suspension and do not dissolve, but other substances like some mineral salts and rocks can dissolve in the water. These mineral salts form ions in water. Some ions found in water are potassium, calcium, magnesium, nitrate, and phosphate. As the water flows towards the ocean, these dissolved substances become more concentrated because more and more pure water molecules evaporate from the rivers. Other substances are also dissolved in river and ocean water that perhaps you have not thought of. Did you know that gases from the environment and gases given off by plants and other organisms living in water are also dissolved into our oceans and rivers? These gases are essential for aquatic plants and animals to respire. They are also extremely important for photosynthesis too.
But Nelly, what is the importance of dissolved salts in water?
Well, dissolved substances are used by organisms as a source of nutrients for biological chemistry within them. When an ionic solid dissolves in water to produce ions, it is termed dissociation. Remember that ionic solids are substances that have been formed through ionic bonding. Ions that are dissolved in water are called electrolytes. These dissolved ions are available for use by organisms living in the water or drinking the water. Once inside an organism, the ions are used in chemical reactions, to conduct electricity such as nerve impulses, and to maintain water balance so that there is not too much or too little water in organisms' cells. You may have heard of electrolytes in sports drinks. These are present because when we exercise and sweat, we lose water and the ions dissolved in it from our bodies through the skin. they need to be returned to the body so that chemical reactions, nerve impulses, and water balance can continue in our bodies. Let's explore points 2 and 3 a little further. In the bodies of living organisms, the ions that conduct electricity during nerve impulses are sodium, chloride, potassium, calcium, and magnesium. I am setting up an experiment here to demonstrate how electricity is conducted in an ionic salt solution. In this beaker, we have sodium chloride dissolved in water. Into it, I am placing 2 graphite rods. If there is a current in the circuit, what would you expect to see happening in the circuit? The light bulb should glow if there is an electric current in the circuit. The light bulb glows, so a current must be passing through the water. If we try this with another dissolved substance, for example, sugar dissolved in water, what will we see? There is no current in the circuit. In this beaker, we have cooking oil. Again, there is no current. Remember, a current is the movement of charged particles in a circuit. Covalently bonded substances such as sugar and oil do not conduct electricity. There are no charged particles formed when they dissolve. When ionic substances such as sodium chloride dissolve, positive and negative ions are free to move. The movement of these ions causes the electric current. Let's have a closer look at the movement of these ions. The graphite rod attached to the positive side of the battery becomes positively charged. It then attracts the negatively charged ions. In the same way, the rod attached to the negative side of the battery attracts the positive ions. The movement of the ions between the rods causes an electric current to pass between the rods. Now, let's turn our attention to the concept of water balance. Dissolved substances in water allow organisms to keep the water balance inside them constant so that they do not have too much water or too little water in their cells. This is possible because of water's ability to move through cell membranes. Look at this experiment. Here I have placed pure water inside some dialysis tubing. The tubing is porous and mimics a cell membrane. I'm going to put this into a beaker of salty water. Here I have some more dialysis tubing, but this time there is salty water in it, and I'm going to put it in a beaker of pure water. If we leave it for a few minutes, something interesting happens. Can you see that in the beaker of pure water, the dialysis tube has become fatter? Can you suggest why this has happened? The dialysis tube has become fatter because water has moved through the membrane into the tubing. In the other beaker of salty water, the dialysis tubing is emptier than it was. This is because the water has moved out of the tube and into the salt water surrounding it. Can you see the pattern here? The pure water always moved into the salty water. Water moves into areas where there are more dissolved ions or solutes to try and dilute them further. This is important for plants and animals because if the water they are living in is too salty, the water will move out of their cells and they'll become dehydrated. If the cells have more dissolved ions than the surrounding water, then water will move into the cells. The cells will be filled with too much water. Organisms thus need dissolved substances in their cells in the correct amounts to keep the correct amount of water in them or the correct water balance. But as we mentioned earlier, it doesn't stop there. Gases are also constantly dissolving in and out of the water in the rivers and oceans, and this affects the amounts of gases in the atmosphere. All organisms need oxygen to respire. Water plants and organisms absorb the oxygen dissolved in the water. Water plants, including phytoplankton, absorb carbon dioxide dissolved in the water for photosynthesis. This process, in turn, releases large amounts of oxygen into the atmosphere. The dissolved carbon dioxide in the ocean is also used to form calcium carbonate in a reaction called a precipitation reaction. The calcium carbonate is used by sea creatures to make shells. Then when they die, the calcium carbonate forms limestone at the bottom of the ocean. People use limestone to make cement, to neutralize acids in soils and lakes, to make glass, and to whiten paper. Do not become confused between precipitation and a precipitation reaction. Precipitation is when condensed water in clouds falls to the ground as rain, snow, or hail. A precipitation reaction is when a solid is formed in a liquid.
Nelly will demonstrate a precipitation reaction for us.
I am going to bubble carbon dioxide gas through a solution of calcium hydroxide. Observe what happens. A milky suspension of insoluble calcium carbonate forms. A precipitation reaction has taken place. Let's write the chemical equation to explain what has happened. The calcium and hydroxide ions in solution have reacted with the carbon dioxide gas and formed the insoluble salt, calcium carbonate, and water. Because some sea organisms use this calcium carbonate to make shells, carbon dioxide is cleverly removed from the water. This prevents the carbon dioxide levels from increasing in the environment.
We have seen how important it is to have water with substances dissolved in it. Grade 10s, I hope you have found this lesson interesting. You'll find more information on our website at www.mindset.co.za/learn. Take care.